In determining whether the lines EF and PQ are parallel, remember that what we need to do is we have to look at whether the proportions for the triangle proportionality theorem are equal or not. So what I mean by that is we want to know, we need to set up, let's see, if dp over pe, we want to know if that ratio equals dq over qf. If these two ratios equal each other, then yes, we have parallel lines for E and F. That's what the converse of the triangle proportionality theorem tells us. But if those ratios do not equal each other, then no, we don't have parallel lines. So let's go ahead and substitute what each is worth. We have distance from D to P is 3.9, and PE is 3. And then DQ is 3.6, and Q to F is 2.4. So I'm going to go ahead and just divide this in my calculator, and I'm going to see whether or not I have actual equal ratios here. In dividing the 3.9 by 3, I got sorry, that's not the pencil I wanted, 1.3. And then when I divide 3.6 by 2.4, I get 1.5. So again, since these two things do not equal each other, right? These are not equal. Then no, we do not have parallel lines. So we would say no, EF and PQ are not parallel. And again, I ran out of room, but reason being that our ratios here did not equal each other, therefore we do not have parallel lines by the converse of the proportionality theorem. So just like the last problem, we want to see if lines DE and CB are now parallel. So again, we have to look at the ratios that make up the side lengths from A to C and A to B, because we are using the triangle proportionality theorem, but now we're using the converse of it. So we're given the side lengths. If you notice, we're given 18, we have 6, we have 24, and 8. So we're given the side portions. Now we want to know if they're actually proportional. If they are, awesome, we have parallel lines. If not, then we don't. So we already saw when we didn't have parallel lines. So now let's look at what happens when we do. So again, I'm setting up proportions from AD to DC, and I want to know if that proportion is equal to AE to EB. Pay attention and be careful as to how I'm setting this up. If I accidentally went AD over DC and I set that equal to EB over AE, I use the triangle proportionality theorem incorrectly. So you need to pay attention and be careful as to where you start. If you start with the bigger piece on top, then again on the other side you need to start with the bigger piece on top as well. So really pay attention to your markings, really pay attention to your side lengths and where you're starting and where you're going. So replacing what I have, AD was worth 18, DC is 6, AE is 24, and EB is 8. So if I do the calculations, I have 18 divided by 6 gives me 3, and 24 divided by 8 gives me 3. So if you notice, I have the same ratio. They came out to the same scale factor, so therefore we can claim, yes, DE and CB are parallel. And again, reason being, when we solved and showed whether the proportions were equal, they were. Therefore, we can claim we now have parallel lines.